Number 8 is going to require you to find the intervals of increasing, decreasing, and also the R stands for relative, so relative max and relative min. Now all this is going to require you to take the first derivative. So let's do that first. Doing the first derivative, you're going to apply the power rule. 4 comes down and multiplies by 2, so we get 8x cubed, and then minus 32x. Next thing we want to do is set it equal to 0. And we're setting it equal to 0 to find the critical numbers. Remember, critical numbers, you have two different ways of finding critical numbers. The first is finding out where the first derivative is going to be undefined, which there's no numbers that make the first derivative undefined here, so you're not going to find a critical number that way. But the second way to find critical numbers would be to set the first derivative equal to 0, like we're doing here. So now we just need to do factoring on that. We're going to factor out an 8x from both of those, and you're going to get x squared minus 4. Okay, so now that's fully factored, except that, well, this one we could factor one more time if you wanted to, or just set it equal to 0 as is. If you do factor one more time, you could do difference of squares, or we could just take an x squared minus 4 and directly set it equal to 0 and solve for it. But factoring it further, you'll get this. Now if you set all of them equal to 0, you're going to get x is equal to 0, negative 2, and 2. These would be considered the critical numbers. Now it doesn't ask us to put in the critical numbers, but that's what they would be. These you have to put on a number line, and that's where you're going to test numbers in each of the intervals to see whether the slope is positive or negative, and that'll allow you to answer these questions here. Let's make a number line. Okay, number line is, we have 0, negative 2, and 2. Now numbers you're testing, remember that these numbers go into the first derivative. So the derivative is actually going to be this one here, or actually you can even put it into this right here. Now the test numbers I'm going to pick are negative 3, negative 1, 1, and 3. So I'm putting them into here. This is that was my first derivative that I factored. So I'm just going to go ahead and use this when I test my numbers. Negative 3 goes in the first one, negative. Into here, it's negative. In here, it's negative. So I have 3 negatives when I plug negative 3 into here. 3 negatives are going to give you a minus. Let's put negative 1 into each of these next. Negative 1 into here, you get a negative for that. But this is positive, and that's negative. So negative, positive, negative. You have 2 negatives will make a positive, so this is going to give you a plus. Next, let's put in a 1. 8 times 1 is positive, 1 plus 2 is positive, but 1 minus 2 is negative. So there's a minus right there. And then 3, putting into all these. 8 times 3, positive. 3 plus 2, positive. 3 minus 2, positive. All of them are positive, so you get a plus there. This is your sign configuration, so now we're going to use that to answer these questions here. For increasing, you have to put the ones that are positive. So it's going to be negative 2 to 0, and then from 2 to infinity. That's going to be your increasing intervals. That's where you have a plus. Decreasing is going to be where you have a minus. Negative infinity to negative 2, and then from 0 to 2. You're only going to have a relative max if you have a plus going to a minus on there. So plus going to minus, you do have that going on right here. It's increasing and then decreasing again, going up and going down. So you do have that happening at 0. So I have a 0 right there. If I plug 0 into each of the x's, I'm going to get a 0 for the y. Remember that when you find your relative max and relative min, you have to plug that number back into the original function, because this is an actual point that's on the line itself. So that's why we have that. Now at negative 2 and 2, these are going to be the relative mins, because it's going down and going up. It's at the bottom of a valley. So if you have minus plus happening, that's a relative min. So relative min, we actually have 2 of them here. So let me put that down here for some more space. Negative 2 and 2 would be the x values for those. if you want to find the y values, you have to plug both of these into the original function and evaluate that. So by putting those both in, I'll just go ahead and give you the final answer there on it for each of these. So if I put, for instance, I'll just explain one of these for you so you can see how it works. If you put 2 in there for there, that's going to be 2 times 16. So it's going to give you 32. And then here you have minus 16 times 4. So you have positive 32 minus 32. So you're going to get negative 32 here. And then if you put the negative 2 in for that one, you're actually going to get the same thing, because when you take negative 2 and you raise it to an even power, you're still going to get a positive number out of that. So this one's going to give you a negative 32 as well. So this would be the actual points that are on the line itself. And so that we've finished this problem, we've answered everything they're asking us for.